Since humans tend to believe that Earth is the center of the universe, we naturally assume that certain events are physically impossible on other planets. However, depending on the location, temperature, and other physical laws, some phenomena that seem unthinkable to us might be possible elsewhere. In fact, the universe is much stranger, more wondrous, and scarier than most of us realize. If you enjoy our videos, please give us a thumbs up and subscribe to Worldview Theory. We look forward to seeing you in future videos. Shadows on other planets versus shadows on Earth are quite different. On Earth, when the sun shines sufficiently, your shadow always follows you. It may change positions and orientation throughout the day, but it is always there. Other people also have shadows, but this is not a universal phenomenon we would encounter on other planets. The only reason our bodies cast shadows is because the sun is our main source of light, and our planet does not orbit around any other stars. However, what would happen if there were two suns? A planet orbiting two stars would resemble Tatooine from Star Wars, with two bright sunsets per day and two shadows instead of one for each individual. This was science fiction until Kepler 16b, a planet orbiting two different stars, was discovered. If you were suddenly teleported to the surface of this planet, you would probably die from the extreme temperatures and lack of oxygen. However, if you were teleported in a protective suit, you would experience your body casting two distinct shadows, a new companion for your shadow, who is perpetually alone on this planet. Another very bizarre place in the universe is a planet that, according to recent research, is completely covered with water. It's an oceanic planet called GJ1214b. The planet is many times larger than Earth, making the Pacific Ocean on our planet look like a small puddle in comparison. Although water covers more than 70% of Earth's surface, it makes up only 0.005% of the total mass of the Earth. On GJ1214b, however, water can make up to 10% of the total mass of the planet. This means that the entire planet is covered by an ocean that is hundreds of kilometers deep and thousands of kilometers wide. Our own ocean extends just 11 kilometers deep, and we have already discovered horrifying monsters with huge teeth and oversized eyes living in the deep sea. Imagine what fantastic monsters might exist in an ocean that is over 10 times deeper than our own. Scientists already know that at the bottom of this vast ocean, hundreds of kilometers below the surface, the pressure would be so incredibly strong that the water would turn into an exotic form of ice known as Ice 7. This ice is not cold but remains in a solid form without needing temperatures below zero. This phenomenon does not occur on Earth, where water needs temperatures below zero to freeze. Stone rain is another extreme weather phenomenon. On Earth, weather is often severe and unpredictable, but compared to other, more extreme places in the universe, it is relatively unspectacular. Take the planet Coro 7b, for example, where it rains stones and rocks instead of water. This is because about half of the planet is red hot at 2,600 degrees Celsius, while the other half is much cooler at 177 degrees Celsius. Just as water evaporates on Earth and condenses into clouds, rocks condense into rock clouds on this planet. These strange rock clouds then rain liquid rock or magma back onto the surface. However, since the atmosphere cools the higher it rises and the temperature on the cool side is much lower, the magma rain often solidifies into rock before it hits the ground. This planet seems to be the closest to hell in terms of its hostility to life. Incredibly fast winds characterize another planet known as HD 189733b. This planet is 63 light-years from Earth, slightly larger than Jupiter, and appears to have breathtaking beauty from space. However, this beauty hides a terrible secret. The planet's atmosphere is primarily made up of silicate particles, which gives the planet's winds their incredible speed of 5,400 miles per hour, or 7 times the speed of sound. Additionally, temperatures on the planet can reach as high as 930 degrees Celsius. The most terrifying aspect is that glass can break on this planet due to its incredibly strong winds, which can reach speeds of up to 2 kilometers per second. If a storm of that magnitude occurred on Earth, it could sweep across the entire planet at the equator in just 5 hours and 35 minutes, leaving a path of destruction from shattered glass. On HD 189733b, one side is always facing its star, where temperatures can reach a scorching 966 degrees Celsius, while the other side faces away from the star and remains very hot at 688 degrees Celsius. This extreme temperature difference is due to a devastatingly fast wind that can reach speeds of up to 22,000 miles per hour, equivalent to 10 kilometers per second, or nearly 29 times the speed of sound. The fastest wind ever recorded on Earth happened during a destructive tornado in Oklahoma in 1999 at 484 kilometers per hour, which is 73 times less than the horrific storm raging on this massive globe. If a kite were made and released into the air, it could complete a full circumnavigation of the globe in just 1 hour and 8 minutes if it had the same speed as the storm. Titan, one of Saturn's moons, is a very strange place. It has an atmosphere, rivers, and lakes, and it rains just like on Earth, but the temperature is so cold, minus 179 degrees Celsius, that the water becomes as hard as rock and methane is present in a liquid state. Clouds, rivers, and lakes on Titan are made of methane, which is the main component of natural gas. Titan is one of the most interesting places in the universe, located in our immediate vicinity. To be more exact, it is one of Saturn's moons. Only 20% of Titan's surface has ever been mapped, but it's estimated that there is 100 times more natural gas and oil in this region alone than on the entire Earth. There's so much gas on Titan that it literally rains gas. This could be the dream of an oil tycoon or a Saudi sheik. Perhaps the best way to promote the facilitation of space travel is to inform countries about the advantages of Titan. Another curious fact is that we could theoretically fly on Titan without an airplane. The atmosphere is thick enough and gravity is weak enough that if you attached a pair of wings to your arms and made a running jump into the air, you could actually fly around the moon like a bird, taking in all the strange sights of rivers and lakes. Of course, you would need a suit to protect yourself, but you could still fly like in your dreams and achieve something that is impossible here on Earth. There are over 1,000 planets that we have discovered in our solar system so far. Planetary weather phenomena. While Earth experiences a range of weather patterns, other planets and celestial bodies in our solar system and beyond exhibit even more extreme and exotic meteorological phenomena. For instance, the planet Venus presents a striking contrast to Earth's climate. Venus has an incredibly thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid. This atmosphere creates a runaway greenhouse effect, making Venus the hottest planet in our solar system, with surface temperatures reaching up to 467 degrees Celsius. The atmospheric pressure on Venus is about 92 times greater than that on Earth, equivalent to the pressure found 900 meters underwater in Earth's oceans. The dense atmosphere also causes winds at the upper cloud levels to reach speeds of up to 360 kilometers per hour, circling the planet in a matter of days, which contrasts sharply with the slow rotation of Venus itself, taking about 243 Earth days to complete one rotation. Cyclonic activity on Jupiter. Jupiter, the largest planet in our solar system, is renowned for its dramatic weather systems. The Great Red Spot, a colossal storm system on Jupiter, has been observed for over 350 years and is large enough to fit 3 Earths within it. This anticyclonic storm system generates winds that can reach speeds of up to 432 kilometers per hour. Jupiter's atmosphere is primarily composed of hydrogen and helium, with trace amounts of methane, ammonia, and water vapor. The planet's rapid rotation, completing a full rotation in just about 10 hours, contributes to the development of its powerful jet streams and turbulent cloud formations. Additionally, Jupiter experiences frequent lightning storms that are much more intense than those on Earth due to the planet's massive magnetic field and the dynamic atmospheric conditions. Saturn's rings and storms. Saturn is famous for its spectacular ring system, composed of ice particles, rocky debris, and dust. The rings are divided into several main sections, including the A, B, and C rings, as well as a plethora of fainter rings. The composition and structure of Saturn's rings are influenced by the planet's gravitational interactions with its moons, which help to maintain the rings' distinct boundaries and shape. Saturn also experiences extreme seasonal variations due to its axial tilt, which is about 27 degrees relative to its orbital plane. This tilt leads to significant changes in the appearance of the rings over the course of Saturn's 29.5 Earth-year orbit around the Sun. Furthermore, Saturn's atmosphere is known for its hexagonal storm system at the North Pole, a geometric cloud pattern with sides measuring around 13,800 kilometers in length. likely caused by a combination of the planet's rapid rotation and atmospheric dynamics. Extreme cold on Neptune. Neptune, the eighth planet from the Sun, exhibits some of the coldest temperatures in the solar system. The planet's atmosphere is composed mainly of hydrogen, helium, and methane, which gives Neptune its striking blue color. The average temperature in Neptune's upper atmosphere is about -214 degrees Celsius. Despite its distance from the Sun, Neptune has been found to emit more energy than it receives, likely due to the presence of internal heat sources. The planet experiences supersonic winds that can exceed 2,100 kilometers per hour, which contribute to its dynamic weather patterns. Neptune's weather is characterized by high-velocity storms and large dark spots, similar to Jupiter's Great Red Spot. Though Neptune's storms are often shorter-lived, Pluto's unique atmosphere. Pluto, now classified as a dwarf planet, has a unique and complex atmosphere that undergoes significant changes. The atmosphere of Pluto is thin and primarily composed of nitrogen, with traces of methane and carbon monoxide. It undergoes seasonal variations due to its highly elliptical orbit, which causes the atmospheric pressure to fluctuate significantly. During its closest approach to the Sun, Pluto's surface ice sublimates, causing the atmosphere to thicken, while it freezes and condenses back onto the surface as Pluto moves farther away. The New Horizons mission, which flew by Pluto in 2015, revealed that the planet has large areas of icy plains, towering mountains, and a complex system of nitrogen ice and frozen methane. The water worlds of the outer solar system. Several moons of the outer planets are believed to have subsurface oceans beneath their icy crusts. Europa, one of Jupiter's moons, is known for its smooth ice-covered surface, which is believed to cover a global ocean of liquid water. The surface ice may be cracked and broken, suggesting that there is active interaction between the ocean and the ice layer above. Similarly, Enceladus, a moon of Saturn, has geysers that eject water vapor and ice particles from its subsurface ocean into space. These plumes suggest that a liquid ocean exists beneath the moon's icy crust, potentially in contact with the rocky mantle, which could create conditions favorable for life. Exoplanets and their diverse conditions. Beyond our solar system, the discovery of exoplanets has expanded our understanding of planetary conditions. For example, exoplanets in the so-called habitable zone around their parent stars are of great interest because they may have conditions that allow for liquid water to exist. The Kepler Space Telescope has identified thousands of such planets, revealing a wide range of sizes and compositions. Some exoplanets, known as hot Jupiters, orbit very close to their parent stars, resulting in extreme temperatures and conditions that resemble a distorted version of Jupiter's weather systems. Others, termed super-Earths, are larger than Earth but smaller than Neptune, with potential atmospheres and climates that might support various forms of life. The search for extraterrestrial life. The search for extraterrestrial life has led scientists to explore diverse environments where life could potentially exist. Astrobiologists study extreme environments on Earth, such as hydrothermal vents and acidic lakes, to understand how life might survive in similar conditions elsewhere. Missions to Mars, such as the Perseverance rover, aim to find evidence of past life by analyzing soil and rock samples for signs of ancient microbial activity. Similarly, telescopic observations of exoplanets focus on detecting biosignatures, such as oxygen or methane, which could indicate the presence of life. Cosmic phenomena and their impact. In addition to planetary phenomena, the universe is filled with cosmic events that have profound effects on their surroundings. Supernovae, the explosive deaths of massive stars, release enormous amounts of energy and can trigger the formation of new stars and planetary systems. Pulsars, rapidly rotating neutron stars, emit beams of radiation that can be detected across vast distances. Black holes, regions of space with gravitational forces so strong that not even light can escape, warp space-time and influence the motion of nearby objects. The study of these cosmic phenomena helps scientists understand the fundamental processes that shape the universe. Future exploration and discoveries. The future of space exploration promises even more exciting discoveries. Upcoming missions to Mars, such as the Mars Sample Return mission, aim to bring samples of Martian soil and rocks back to Earth for detailed analysis. The James Webb Space Telescope, launched in 2021, is designed to observe distant galaxies, exoplanets, and other celestial objects with unprecedented clarity. Advances in technology and international collaboration will continue to push the boundaries of our knowledge, uncovering new insights into the nature of our universe and the potential for life beyond Earth.